Tom came. And before I introduce the speaker, I just want to remind people that there's an online audience, and this session is being recorded. So don't say anything or imply anything you don't want like potentially showing up on the internet. You smile, but we had somebody a couple of sessions ago say something that she then requested that we don't post for fear of creating problems with a sister institution. So, in any case, we're lucky to have Christina Brown join us here today. So Christina is the SAE.
SAE.
Damn it.
It's not intuitive.
SAE, Family Fellow in Economics at the Becker-Friedman Institute at University of Chicago. She'll be joining the Chicago's Economics Department as an assistant professor in 2023. Christina is a development economist who studies labor and behavioral economics questions. She finished her PhD in economics from Berkeley and worked as a consultant for the World Bank and Save the Children. But most importantly, prior to becoming a researcher, she taught high school physics. So she comes by this research honestly. So we're gonna go for say an hour. And then let's save like the last 10 minutes or so for questions. And if there are clarifying questions throughout, please feel free to ask them.
Great. Thank you so much for that introduction. Let me know if the mic is okay and if there's any feedback. But I'm delighted to be here and particularly excited to present this project because I think this audience, a lot of the members in this audience might know more than me about some of these topics. So really looking forward to getting your feedback. And feel free to interrupt if both clarifying and if there's more substantive questions that you just really can't wait for. Happy to chat and do more econ style conversation. Great. So I don't think I need to do too much to motivate this audience on this question, but there's tons and tons of evidence that schooling, in particular good quality schooling, has really long-term impacts on a variety of outcomes for kids. So labor market outcomes, criminal behavior outcomes, health outcomes. And there's a long kind of educational theory literature that says, well, part of this could be coming from the actual content and skills that kids are learning, right? They're learning literacy and numeracy, and those have returns in the labor market. But we might also think that schooling does other things too. It might actually shape children's ability to focus on cognitively difficult tasks, right? It might inform their abilities to have kind of sustained attention or improve their working memory. And these might be general skills that they can use in lots of avenues of decision making. And this kind of second piece is a much more expansive view of what we think education or schooling might do and how it affects human capital. And we just don't have a lot of evidence on that second piece of how schooling could operate in this way. So what we're going to do in this paper is try to kind of zoom in on two particular things. So we're going to say, okay, one feature of schooling, one specific feature is that in most cases, especially in developed country settings, kids end up spending a good amount of the day focusing on kind of effortful, cognitively challenging problems for an extended period of time, right? For their math class, they're focusing on working on math for 50 minutes. And so this is kind of the aspect of schooling we're going to be focused on. And then the outcome that we're going to be interested in is extent of cognitive endurance that kids have. So another way you can think of this is some people call this like sustained attention. This is the ability to focus on something cognitively challenging for an extended period of time. And so we're going to try to understand the extent to which this type of feature of schooling might end up influencing this underlying cognitive capacity in kids. So really briefly, just to kind of orient us, what do I mean by cognitive endurance? All this is your ability to sustain your performance over time on a cognitively effortful task. So think about your ability to ask thoughtful questions at the end of this seminar versus the beginning. Your ability to maybe focus on a challenging task at the beginning of the workday versus the end of the workday, and so on. And one thing that we see in a lot of data in a variety of settings is that in general, performance tends to decline over the workday, over the classroom period, over the length of academic tests. And so, this is something that we think is kind of in lots of different settings could show up as an important kind of feature of performance. So let me just give you one piece of observational data on this. So if you look at the TIMSS data and the PISA data, you can look at question level information for students' performance. And a nice feature of both of these tests is that they have block randomized kind of booklets of the test. So depending on what booklet order you're getting, you might be getting some certain questions coming earlier or later in the test. And what you see is that if you control for question fixed effects, so you actually control for the difficulty of the given question on average, if a student happens to get that question at the beginning of the test versus got a booklet where they had it at the end of the test, they do significantly worse on the same question item if it appears later. And you see this across the board, both in developed and developing country contexts. And these aren't particularly long tests, so this is kind of over a 40-minute period, whether this question here is minute 0 versus minute 40. Yeah.
So, Christina, how much of that is due to they just didn't finish the test, as opposed to they took it, they just got it wrong?
Yeah, exactly. So we can restrict this for just attempted questions. So, exactly, we might be worried either that they, didn't finish it for some reason or something like that. And we see these patterns, they're not quite as big, they're a little bit smaller, but we still see performance declines even for questions where there is some answer provided. But I agree that that doesn't perfectly nail it because maybe they were just, filling in, any answer at the end or just guessing all at the end. So on our test that we administer, we're going to do a lot of work to make sure that kids have time to finish it. It couldn't just be about this, not having time. And yeah, again, we see this, across exams all over the world. The other really interesting pattern you see is that there's a lot of difference in the extent of cognitive decline on these tests. We see that lower income groups tend to have more performance decline. I will flag on these graphs though, and this is impossible to see with how small these figures are, but the axes are different here, so there is a level difference here. It's not that low SES and high SES kids are performing identically at the beginning of the test. We just took out the level differences so it's easier to compare the slopes. But the slopes are important. They end up accounting for about 10% of the test score gap that we see between black and white students in the US. And so, this is suggesting that, it's not just that there's differences in terms of content knowledge of low and high income groups, but it might just be in their ability to take a test or to do these types of tasks where they're expected to do challenging work for an extended period of time. So that was a little bit of the motivation for going into this project. And why might we think that schooling itself could affect your ability to have cognitive endurance? Well, some of the motivation comes from the psychology literature. So there's been increasing amount of papers where they try to kind of train these types of skills. So they try to either train working memory or they train sustained attention by having kids come into a lab and do different types of kind of tasks where they're practicing these skills and then trying to see if there's some spillovers of these skills to other types of tasks. The other thing we can do is look at the actual TIMSS data to see, well, what is it that teachers are doing in these schools? So if we see these performance declines where kids are getting worse over the length of the test, are there some schools or some settings where we see less of this, where there's less decline? And what is it that they're doing in their classrooms? So in the teacher time use survey that comes in the TIMSS data, they have some questions about how much time they spend on, lecturing versus kids working on practice problems independently. And the first thing you see is that both internationally and when you look within the US for higher versus lower income students, in higher income settings, students are spending more of their classroom time on independent practice. So kids are getting more time to kind of work on the problems themselves or maybe in pairs, whereas in low-income settings, they're being lectured at. So this non-ideal style of teaching that I'm doing now is what you see in a lot of low-income countries. And then when you look at basically then trying to see, what are the cases where students are having more or less decline? So this regression specification, the outcome is whether the child got the question right income levels of the country, the item location, so this is basically showing you how much decline there is at the beginning of the test versus the end of the test. So for a question item that appears at the end of the test relative to the beginning, they're getting it about 13 percentage points less than if it appeared at the beginning of the test. But you see that this kind of question location decline is significantly less if you were at a school where your teacher was spending more time on independent practice, where kids were getting more opportunities to kind of practice this skill or this flex this muscle of working over time. This is just kind of correlational, but this was something that helped us kind of motivate the experiment that I'm going to tell you about. Okay. So let me just preview the experiment itself really quick so you kind of see where we're going with this and what kind of data we had. So we conducted an RCT with about 1,600 students in 6 low-income private schools. And what we did is we kind of popped into what was normally their elective period and randomized students to a couple different kind of versions of their elective period. We had 2 different versions of the kind of treatment arm that we were doing. So in some school, or some kids ended up getting the math version of the cognitive practice arm. And so those kids are going to get a tablet, and they have some kind of basic math software where they're going to be doing problems that are similar to the content that they'd be seeing in their class. And the problems get harder or easier depending on the student's performance, so it's dynamically adaptive. In the non-academic version of that, kids are also going to get a tablet, but they're going to get some game or activity that doesn't have any kind of literacy or numeracy requirements. So it would be things like mazes, tangrams, puzzles that they're going to be working on. So it's kind of cognitively challenging to work through and is also similarly dynamically adaptive, but there's no academic content in the task itself. And then this is relative to a control group where the students are just working on some homework problems and ends up meaning that they're focusing for maybe half of the class period, a little bit less, as opposed to the treatment group that are focusing for about 25 minutes straight. What we find is that overall, for kids in either of the versions of the treatment, we see less performance decline over a variety of tasks. So after the intervention, we go in and do a listening comprehension test, a math test, a Raven's matrices test, and we can look item by item, and we see that the decline over the length of the test is much less for kids who were in the treatment group. We also see that overall in their school performance, so in their grades at the end of the school year, in subjects unrelated to things that we were training, like Hindi and English, we also see improvements in their overall grades at the end of the school year, suggesting that this underlying skill of cognitive endurance might have allowed them then to be able to focus better in their classes, learn more content, and then ultimately do better on their end of year exams. So those are kind of the first results I'll show you, and then we'll try to get into the mechanisms to understand, okay, for the treatment that we were introducing, what was it actually changing? Is it, there could be lots of different things that could have been affected by a program like this, and so we'll try to show you some evidence that we do think it's this kind of cognitive endurance or sustained attention channel that seems to be affecting the results that we see. We'll show that through kind of positive evidence for sustained attention, so we use some kind of traditional measures of sustained attention from the psychology literature and show that we find effects on those outcomes. We'll also show you that we don't find evidence on some other mechanisms, so we don't see an effect on grit or kind of a differential effect of motivation for these kids, and so kind of negative evidence for these other potential channels. And then lastly, if I have time, we have another set of data from another setting where we then are able to show that for kids that have an additional year of schooling, we also see that those kids have better cognitive endurance as well. So kind of showing that in general, schooling, not just our particular intervention, seems to improve sustained attention. So in general, this paper kind of, I would say, broadly speaks to 2 big literatures. The first is really more about the extent of kind of cognitive endurance, cognitive fatigue, decision fatigue. Sometimes you hear those terms thrown around a lot. And a lot of this is in the kind of psychology literature on the existence of these cognitive functions, as well as the ability to kind of possibly train some of these. as well as there's been a bunch of econ papers that have basically showed the existence of this being an important thing in lots of different labor market and decision-making settings. Second big literature is really then thinking about what are the broader ways that schooling affects human capital, so beyond kind of rote literacy, numeracy, other kind of skills and content, what are the broader things, either in terms of, maybe socio-emotional skills or non-cognitive skills that schooling might impart on kids, and how does that then translate into, later life outcomes? So those are the two big kind of categories we're speaking to, yeah.
A friendly addition to category two, maybe as a subset, is like contribution to exist, even if we never tested kids, right? So like this is a skill that's being built that's valuable in the labor market. But we see it in tests. So I think there's also a contribution here that like put this on the positive side of using tests as near-term measures of educational interventions, that like we know tests are capturing more than just math and reading ability, but here's a great example of something they're capturing that is positive, that is not just math.
Yeah, there was a nice paper that basically showed that countries, this was cross-sectional, so I'm not sure if it nailed the causal identification, but it showed that countries that they basically had students' level performance at the beginning of the PISA test, and the rate of decline over the length of the test, and they showed that both of these were correlated with GDP later on, that basically like both of these things might be important for labor market outcomes, and maybe these are different skills. And so yeah, I like that idea that like maybe our tests are giving us more information than we think.
Usually people like to tell us the negative things about it.
Exactly.
Here's a positive.
Exactly, yeah, with the like these are two interesting dimensions that we can pick up of what they're doing. So yeah, love that. Great. Okay, so jumping into the experiment itself. So we were working with, as I said, 6 low-cost private schools in India, and as you can see, these are quite low-income settings, and the majority of kind of instruction that kids are introduced in this setting is, basically lecture. So for about half of the class, the teacher is lecturing at the kids, maybe writing information on the board, and the kids are copying it down. And usually for the second half of the class, they're like having one kid come up to the board and answer questions. So that's the type of instruction that kids are used to in this setting. And so in general, what kids are basically experiencing is maybe they're having the opportunities to do like a couple problems or answer a couple questions per class period. And they have some homework assignment, but completion is pretty low. So the opportunities that kids get to just sit and focus on something for 20 minutes straight is almost non-existent, both during their school day and out of their school day. So what we're going to do is try to do something to basically increase the extent to which they're having to spend an extended period of time on something cognitively challenging. And so we needed something, one, that would be cognitively challenging and engaging enough, but not so engaging that it was too kind of exciting for kids. And so what we ended up doing was using software that was dynamically adaptive so that it could get easier or harder depending on how the kid was doing. And in this setting, kids don't have access to technology, so this wasn't something that was familiar for them, but it was kind of novel enough that it allowed them to focus for about 20 to 25 minutes during the lesson. Though this was in primary school, these are grades 1 through 5, and like getting a first grader to do anything for 25 minutes straight is tough. So we were like right at the edge of their cognitive endurance by the end of the lesson. Okay. So the different versions of the treatment, so we have what I'm going to call the math practice arm. So again, kids are getting these tablets that have math software. This is by Pixatel, and they're getting basically basic math problems similar to the content that they'd be seeing in their class. And then it's getting harder as the kids are doing better. In the games arm, kids again have a tablet, and they're gonna get basically the most boring versions of games that we could find on the App Store, but it would be things like mazes, tangrams, puzzles, these kinds of things, but I would say, least gamified version, it's not like Candy Crush. It's kind of a stripped down, boring version of puzzles to work on. And then in the control group, they're getting their kind of traditional study hall where they're given some homework problems to work on. Typically what this means is kids work for, maybe 10 minutes or so of the 25-minute period. And so, they're not getting a ton of opportunities for practice here.
Is it randomized at the school level?
This is at the child level. Yeah.
So in a classroom, kids are sent out to do study hall?
Yeah, so normally the way that it works between the different classes is they'll have like their math class or English class, and then they would be going to their regular elective, which sometimes it would be like the art class or the computer class or something like that. For this particular elective period, they then just go to like the control class, or one of the 2 treatment classes. So they're already used to kind of getting split up for elective classes before. This is just for our particular elective class. And these classes were taught by our program staff. It's not their regular classroom teachers. Yes.
So Emily, or Christina, sorry. Do the control kids get to do stuff with tablets? Like,
Yeah.
so it is it that, especially if you're going to measure the outcomes later using tablets, just getting accustomed to, making your way around a tablet?
Exactly, yeah, familiarity with that modality. So our assessments won't be on tablets, so that'll help with that. But there might be lots of other things. Maybe they just, are super excited that they're in the treatment group. I get access to this technology that I've never had interaction with before. So for even the control kids, at the beginning of the intervention, we had like a 2-week period where everyone got tablets. And we did, maybe not the nice thing, we did like a very boring task on the tablets for all the kids. So it lost the shine of getting to interact with tablets. So that by the point we got to the actual kind of intervention period, it wasn't like, oh, this is the good class to be in and this is the bad class to be in. If anything, in the control class, they got to like spend time talking with their friends. So it was maybe even slightly preferred. Great. Yeah, so then you can think of basically during these 30-minute elective period classes is that in the treatment group, they're getting about 20 minutes of sustained practice as opposed to the control group, which is getting somewhere between 10 minutes-ish of sustained practice. And we did this over a period of 6 months, and this is going to give then the treatment group about 10 additional hours of focused practice relative to the control group.
Christina, so I'm just trying to understand why the students, if it's not more like exciting, why are they more sustained? Is it just that it's adaptive so they can actually complete it, or?
Yeah, I think partly that it's adaptive, that they have something that's kind of constantly coming at them in terms of like there's a new problem to work on as opposed to, a workbook or something written where I guess it doesn't feel quite as engaging in that way. I think that was the biggest thing, is that it's both kind of at the right level, so they're not going to get either frustrated or bored, and that it's, there's constantly more to be done, basically. There's no end to it. Yeah.
So one of the things I've noticed in my own practice as a learner is that often I've been put off by tasks that sort of require sitting down for a longer period of time because it's difficult. I don't make any progress at first, and then after like sitting down for 15 minutes, then I make some progress.
Yeah.
So I'm wondering how much of, should we be thinking of cognitive endurance as the ability to concentrate on one problem for a sustained period, or to be stimulated for a longer period of time by successive problems? And it seems like I myself notice that I actually learn when I can sustain my focus for a long time on one. And it's rare that I'm able to do that successfully.
Yeah, with our design, we're not going to be able to separate out those two things. I would say our working model of cognitive endurance is really your ability to persist in the face of something that is effortful, cognitively effortful. So that could be a new challenging problem. It could be the same problem that has kind of multiple parts that you kind of need to keep working through. That's our working model of it, though I won't be able to show you differences in the data on that.
So on this point, is there any data that you have from the adaptive software that might suggest did kids did over the course of the months, did they keep getting harder and harder, or did they just sort of practice the same kind of level?
Yeah, I won't have that here, but we did have data on basically, what questions kids are completing and are they kind of ramping up the difficulty, and we do see that, over the length of the intervention, they're kind of getting to harder and harder modules, and the software was kind of designed in such a way that, they should, I think it was something like 70% of the questions or so they should be getting right, and so it's kind of targeting that level of performance as it's, ratcheting up. So that's kind of what we see over the length of it.
So maybe in that first one, is it fair to say then that it's sort of both sustained attention repeatedly, but also it's pushing their, I don't know, the difficulty of that sustained attention?
Yeah, that's a good point too. We should kind of look at basically like what topics are they experiencing as they, and like what does the difficulty look like over time? Yeah.
I think I thought I understood it, but now I don't. The control group, in principle, could be spending 20 minutes doing sustained attention things. The treating, the difference is the control group has a static set of problems that they're working on. The treating group has nominally an adaptive set of problems that we're part of the games branch for a moment. Is somebody pushing the kids to actually do stuff differently in these two arms? Or like, why aren't the control kids doing work, and why are the treated kids doing work?
So one thing is that they would run out. So for the control group, the teacher's writing like 5 problems on the board for them to do. And so they're usually doing those and then finishing. And that takes, around half of the period, maybe a little bit less. So some of it is just they're running out of stuff to do. In theory, they could like go to their textbook or do something else to kind of keep working on something. We just don't see, maybe unsurprisingly, 1st through 5th graders kind of having that initiative to keep working. The teachers, though, are doing the same thing in terms of kind of monitoring or external pressure. So in both cases, they're basically sitting and telling kids, you need to either do the problems on the board or you need to do the work on your tablet, and then they're sitting and doing grading up at the front of the class. So they're kind of, the role or the kind of external pressure from their teacher is the same in both of them, but I think the potential for them to keep working in terms of just like the capacity for more material to keep coming at them is one of the key differences.
So would you say, one last follow-up, could you have run this experiment where the control group has 5 questions and the treated group has 20 questions? And would you expect to see the same effects?
Potentially. So I think we don't know basically to what extent it is just as long as there's something for you to work on that is enough, versus it was something about the tablet that was novel enough to get them to kind of keep focusing on that. We won't be able to speak to kind of, and I think I definitely don't want the takeaway to be like tablets and like dynamically adaptive software is like the way to go. I think it's just that this was a modality that seemed to be working in this context. Maybe because of the novelty, but we can't separate that out exactly.
But you earlier claimed you burned out the modality by boring them with the tablets to start.
Yeah, so I will say it's not that it's I would say there's kind of like two different ways that you can go with tablets, and a lot of the software is, some is a situation where it's low effort required to continue to engage with that thing, right? So if you've ever seen, like a 6-year-old on some tablets and they love this game, it's like impossible to pull them away. That was not what was happening in these classrooms. It was like, it was fine, but the kid, by the minute 25, they were like really ready for the period to be over, like they were bored. And so we were like right at that edge of kind of they're willing to engage. But it was, I think if we had given them a worksheet, we wouldn't have even gotten to minute 25. Like that wouldn't have been able to get them that far. That makes sense.
I stole the question.
Yeah, sorry, I have a question. I'm sorry if I missed or misunderstood this, but when they're working on the tablet, are they getting like instant feedback on the exercises that they're completing, or is it the same format as like you would with a worksheet where you have to finish everything and then your teacher either gives you feedback or you wait till the next day? So I'm just wondering if there's like that instant gratification where you're getting like feedback immediately and you're like, all right, I'll do the next one, or is it like also like you wait to find out if you did a good job or not?
That's a great point. So that is another difference too between the two arms, is that in the Under the tablets, both in the math and the games one, they're basically learning whether they got the question right or whether they got the puzzle right, or they complete the puzzle. Whereas on the in the control group, they're getting these 5 problems, and then at the very end of the class, the teacher grades their problems, so they get some assessment at the very end, but it's not immediate, and so it probably doesn't have the same kind of bite. In terms of intervention, so we're going to go in at the beginning of the school year, or at the beginning of the kind of our version of the school year, and do a baseline test. We then run the intervention, do a midline test, have about another month of intervention, and do an endline test, and then we have some follow-up testing about 4 months later. Okay. So first off, I'm going to show you some of the results on kind of the cognitive endurance tests. And so these are tests where, similar to kind of the style of TIMS, we're going to be able to randomize question order. So we're going to have questions that appear at different parts of the test for different students, and include question fixed effects. So we can control for the difficulty of a particular question item and just see, are kids doing worse or better if this question appears earlier versus later. To solve some of these problems that were brought up before with TIMS potentially, for all of these, we really made sure in piloting, kids had plenty of time to complete this. We can also look at whether the student actually wrote an answer versus not, and do some analysis by that. So we're going to do this in 3 different subject areas. We're going to have a listening comprehension test, Raven's matrices tests, and a math test. So in the listening test, what the goal was, they had basically headphones where they were listening to a story told by a teacher, and then they had to answer some factual questions about the story that they had just heard. And it's kind of a slow, they have a 2-minute story, and then there's a bunch of questions that are asked afterwards where it's repeating the question multiple times and kind of slow dictation to hear all of the answer choices. All of the answers are pictures, so there's no literacy requirements. This is just, did you listen to the story, and can you remember that information? For Raven's matrices, it was similar to Raven's matrices, which I'm sure people are familiar with in this room. We didn't have them kind of progressive in the way that Raven's matrices traditionally are, because we wanted to randomize question order, so that is one distinction. And then for the math test, again, these are just typical questions that they would have seen on their end of term exams. Okay. So the first thing is that, similar to what we saw in the TIMS test, we do see performance decline over the length of the test. So this is for the listening test, and we see about a 3 percentage point decline from the beginning of the test relative to the end of the test. This is for the control group. For the treatment group, we see performance is basically identical at the beginning of the test, and then halfway through there's this gap that opens, and by the end of the test there's a significant difference in performance by about a percentage point. So we see less performance decline for the treatment group relative to the control group. We see a similar pattern for Raven's matrices and math, where there's some performance decline for the control group and less steep decline for the treatment group over the length of the tests. And then this bottom row is splitting by the math versus games. So again, we see a pretty similar pattern, less decline over the length of the test, flatter performance for the treatment group relative to the control group.
So, Christina, isn't the Raven's matrices, isn't it sort of designed to pick up this skill you're talking about? It's designed to see at what point do you just give up and just say, "Oh, the hell with it." I think it really, in fact, isn't that part of its design? So it's sort of it's designed to pick up this cognitive endurance.
Yeah, I think that was something that we kind of wanted for this, right? There's no, innate kind of content knowledge that's required for that. It's just persisting and kind of trying, all these different options and thinking through all the different approaches. And we also wanted to try to make it so that at the beginning of the test, kids were doing relatively well. That again, this, it's not something about unfamiliarity with these types of questions. We do lots of practice versions with it. So I think, that was one of the reasons we kind of chose this particular test, was we felt like, it's to a certain extent free from kind of content requirement. So. Yeah.
I'm trying to understand how the randomization of the item on the test works. So, like, you have a bunch of students, and some of them are treated, some of them are control, and within the treated group, you split those students up by different test locations, or item random, you know what I mean? But then how are you making the comparison? Like, were you doing something to make sure that the students in the control who got a certain item location are similar to the students in the treatment who got that item location? Like, what's that comparison being drawn?
Yeah, so we made sure that basically there's balance in what test packet you get by treatment status. So we're stratifying within treatment status the test packets. So there's I think there was 6 different test packet versions that have different orders of questions. And so I don't think I have it in my slides, but in the paper itself, we show that, okay, there's balanced in terms of, it wasn't that just by chance the control group got the test where all the hard questions appeared in this part of the test and so on. The other thing that we can do too is that I think these figures, yes, so these say residualized, so these are all residualizing out the average question item performance. So we say, on average, for this, particular listening comprehension question, or for this, addition question on the math test, what was the average performance on that question, no matter where it appeared on the test. Let's residualize out, let's add in question fixed effects. Now we're just gonna look and see, how much worse did you do on this question if you happen to get it early versus later, relative to the average performance on this question. And does that look different by treatment and control? That makes sense.
Yeah, okay, but within packet of items, you're not making sure that the control and treatment look the same there. It's overall.
Exactly. So we're not having to, because treatment and control was randomized, on average their performance looks similar, and then we're cross-randomizing what packet version you got within treatment.
Okay.
And we can show in the balance tables that it doesn't look like we just got unlucky, and that the group that got, one version of the packet was systematically different in control versus treatment.
Yeah.
Yeah.
Just for, because I had a sort of similar question. You didn't have to do that. You could have just used a fixed form, right?
Yeah.
For everybody. But you wanted to generalize across as many items as possible, is that right?
Yeah, because we would need to have some information about question difficulty, and so we didn't want, for example, that maybe our treatment is making them better at the hard fractions questions that appeared later, and there was no effect on addition questions because the tablet software was bad at teaching that skill or something like that. And so we wanted to make sure that it wasn't about the types of questions that we put at the end of the test versus later in the test.
I can help this. So why is the middle graph so noisy versus the left graph so clean? So I'm just trying to figure out what's going on under the hood here.
Yeah, so part of it is between this one and this, there's 2 different things for why these look this way. From this one to this one, there's just a lot more performance decline over the math test. The test location maybe isn't the right running variable here. We should think a little bit about this in minutes. So the math test was a 30-minute test, the Ravens test was a 15-minute test, and a listening test was about 8 minutes. And so there's just way more decline, and so because when you zoom in on this axis, if I zoomed in on this level of access, it would look noisier, if that makes sense. So that's why from here to here.
Actually, it's a y-axis issue, right?
Exactly. From here to here, you're seeing a similar level of decline, but we only had 3 questions after the story passage, and so I only have 3 points. So my bin scatter is less of a bin scatter than this is.
So for the listening, there's only 3 questions, but you just delivered them really slowly in a painful way to see if they just gave up?
Essentially, yes. So it would be like, you just heard the story by this teacher telling you about the bear in the forest. What was the color of the, shirt that the bear was wearing? Was the color of the shirt yellow? Let me repeat that answer. Was the color of the shirt yellow? And so it took 2 minutes for each question, basically. So it was a 2-minute story, and then 2 minutes for the first question, 2 minutes for the second, and so on.
Vaguely sadistic.
Maybe, yes, fair. Yeah.
I guess I'm thinking and really curious about, maybe you have some stuff on this later, but I feel like there's something different cognitively when a teacher tells you to do something versus like when it's self-directed. And in this case, if your decline happens because this like robot voice is stretching out, but like, what do you think about those different cognitive processes? Or are you kind of considering them all similar?
Yeah, so I think maybe one thing that's underlying your question is that, you know, the extent of cognitive decline that we see depends on the incentive that the child has to do well on this test, right? You know, whether they care about this thing, whether this feels like, oh, this is something for some research study, I'm not even gonna, you know, I'm just gonna get bored as the test goes on. That could be coming from pressure from the teacher, it could be coming from, you know, whether they think this test has stakes for them. And so I'll show you a little bit of evidence where we try to increase the stakes and see basically, does that affect your extent of cognitive decline? And it seems like it doesn't actually. So it improves your initial performance, but not your rate of decline. And so it seems like this might actually be a binding constraint for kids, even if they really care about doing well on the test. If you just don't have the muscle memory to do this thing, even if you care a lot, we can't get them to kind of reduce the extent of cognitive decline we see. So I think, you know, irrespective of basically how much pressure the teacher is putting on them, I think this would be something that would be a feature no matter what. Okay. So I showed you just kind of graphical evidence. Let me actually show you some regression evidence to these same points. So the first thing that we can do is just say, okay, I'm gonna you know, have as my outcome whether you got the question right. And then I'm gonna have what your treatment status was, the location of the question item, so was this in the first decile of the test, so kind of the first you know, 10% of questions in terms of order, was it in the second decile, and so on. And I'm going to bin and say, you know, I'm going to compare basically how did kids perform in the beginning of the test relative to, you know, when this question was in the kind of middle of the test, so second through fifth decile versus the second half of the test. So I'm going to look at performance, students' performance on different kind of parts of the test to see how they do. The coefficient of interest here then is going to be beta 3, which is basically, you know, what was the differential decline for treatment versus control kids. But it'll also be interesting to see what was the beginning performance different, right? So one thing we might be worried about, especially once we start thinking about mechanisms, is like, you know, maybe, again, if kids were just super excited about having a tablet, so they all of a sudden showed up to school more and were absent less, this could end up, you know, affecting their overall performance on this type of task. They might just, you know a lot more math, or might, you know, have much better listening comprehension skills as a result. And so that's going to be also kind of help us shut down some other potential channels or other potential mechanisms we might be worried about here. Okay, so the first column here then is showing for overall pooling across the two different subtreatments, we see that for the kids in the treatment group, we're seeing about 13 percentage points less decline, or 0.13 percentage points less decline over the length of the test, which ends up being about a 20% reduction in decline over the test. So we're seeing, you know, a significant amount of less decline over the length of the test in the second half of the test for the treatment versus control group. The other interesting thing that we see is we don't actually see any difference in their performance on that first decile. So in the first set of questions that they're seeing, we don't see a difference between treatment and control group. Similar patterns when we split this up by the math version of, or the games version of the treatment that we introduced. And again, really not much happening in terms of, you know, difference in performance in that first decile. Okay. So that's one approach that we could take in trying to look at the results, but that's a little bit limited because we're saying, okay, all I care about is their performance in the second half of the test, when really we might be able to use the, you know, more of what's going on in the data, because it could be, you know, for example, for the math test, because it's a longer test, maybe kids are declining much more. Maybe for the listening test, there wasn't as much decline because it was shorter. Maybe for first graders versus fifth graders, there's different extent of decline. And so what we're going to try to do then is really leverage the data and say, well, let me look at the control group's performance or the baseline test performance and say, you know, by the third quartile of the math test, I would have expected you to decline by this much. So this is kind of a part of the test where I would have expected decline to have kicked in. And let me see, is there more or less of a treatment effect in those places in the test where in the baseline we saw more decline happening. So we're trying to kind of look at heterogeneity of treatment effects by the place in the test where we would have expected to see more decline. So we're going to have a relatively similar specification, but now we're interacting with this predicted decline measure. And this measure is coming from basically comparing what's the average performance in the beginning of the test, so in decile 1, minus the performance at the baseline at this part of the test for this grade. So we're saying, by this part of the test, how much worse are you doing relative to how kids are doing at the beginning of the test? And so this might pick up that there's, a lot of decline in the middle of the math test, or a lot of decline right at the end of the Ravens test, or something like that. And then again, the coefficient of interest is going to be this interaction to say, do we see more of a treatment effect in places where there's more or less decline that would have kicked in by that kind of place in the test? Okay. So similar to kind of column 1, then first panel, we're pooling across both of the subtreatments. And again, we see these pretty significant effects where the treatment seems to have more of an effect in the places in the test where decline would have kicked in, where on the baseline test, kids were experiencing more decline. We see really similar effects both for the math and games subarms, and again, really no effect of the treatment in the places in the test where there was no decline relative to the beginning of the test. I'm just going to pause for a second for those results, yeah.
Forgive me if you're getting to this later, but kind of related to my earlier question about what kind of sustained endurance we should be thinking about. I know your item level fixed effects absorb away the difficulty of different items, but in one sense, you might not want to absorb away the difficulty. It might be really interesting to look at how, like, regardless of where they're placed in the order of the test, it might take cognitive endurance to focus on a harder question in a different way than an easy question. And is that going to be something that you look at?
Yeah, I think I don't have it in these slides, but we have in the paper basically, is there heterogeneous treatment effects by question difficulty?
Yeah.
We actually don't see much on that, but our confidence intervals are pretty big, so I would say there's, I don't want to hang my hat too much on those results. The other thing that I will show you, we'll look at basically, is this just kind of grit in that you're able to better respond after a hard question? So how do you do after you've seen a difficult question? And that doesn't seem to be the case. It's not that we're making kids just better able to respond after a difficult question item. It's just that in general, they're doing better later in the test.
So that's pretty interesting if you don't see like clear evidence of this ability to work harder or work on harder questions, because then the cognitive endurance is something like you're able to maintain your ability to work through stimulation or something, which is very different than maybe what some people have.
Yeah, I think the maintenance is a good word, exactly. You're just able to maintain the level of effort that you had in the beginning of the test later. It's not that you're kind of, more willing to do hard problems or kind of work on more difficult items. Yeah.
The definition of difficulty here is like the portion who get it right in a binary sense.
Yeah.
But then each question may actually have a different like point value in the test, and
just so I understand, so there are like 30 questions on the math test, so each decile is only 3 questions,
Mm-hmm.
and then they're not always the same questions because one gets randomly placed across different groups? Yeah. Okay. So then so how should we interpret what a decile means if it's not constant?
So that's a good point. So because we're residualizing out question fixed effects, it could be that, for example, we're not seeing every question appear over every decile, but because we've differenced out the average difficulty of the 6 versions of questions that appear, there's some overlap between a question that appears in one with every other decile, if that makes sense. So of these 6 types that can appear, they're going to appear somewhere in the other deciles at some point. Just splitting up by the different subtests too, Again, patterns look relatively similar. So both when we kind of look at the non-math items, so these results aren't just all driven by the math test, for example. We see, treatment effects across the board. Once we split up by both sub-treatment and sub-test, some of these effects aren't statistically significant, but I would say qualitatively the patterns look relatively similar. The one exception to this rule that I talked about where, there's really no difference at the beginning of the test is, as we'd expect on the math test, the games arm does do worse, right? Because both in the kind of status quo control version and in the math treatment, they're doing math work, whereas the games arm is just doing puzzles, so it makes sense that at the beginning of the test, we would have these level differences for those three. Okay. We also, go back 4 months later, we see very similar results, if anything, similar in magnitude. Okay, how am I doing on time? Yeah. So really quickly, just going through a couple of the different channels that we try to test. One, try to see if we have some positive evidence for this sustained attention or cognitive endurance channel by using more traditional measures of sustained attention from the psychology literature. So we're going to do this for a couple different tests. We're going to use the SART test, which is the Sustained Attention Response Task, which is a computer-based task where kids respond to different symbols that come up and have to kind of quickly click the space bar as those symbols appear. Because it was a computer-based task and we thought, maybe tablets, there's some, level of comfort that kids have with technology, we also used a paper-based version of this task where they have like a matrix of symbols that they have to identify the right symbol, and it's just kind of like grunt work of going through and finding the right matching symbol. And if we look at these results combined as well as splitting by the sub-treatments, we see decent size effects on both of these, for both of these sub-treatments on these kind of more traditional psychological measures of sustained attention. The other thing that we can do is try to pull from another aspect of the psychology literature, measures of ADHD. And so we adapt the Vanderbilt ADHD behavioral tool, which is generally used by teachers and parents to rate kids on levels of attention. We can't have all of the question items that are there because we wanted a treatment blind observer to do this observation. So we couldn't have the child's regular teacher do this. We had to have someone that could just sit in the back of the classroom and rate the kids on some of these measures. We had a task completion measure, kind of response to stimuli, and then physical signs of inattention, which would be like, looking around, maybe fidgeting in your chair, these kinds of things. And so when we pool this is reverse. We reverse the sign. When we pool all these, we see it does seem like our treatment group has, some effect in terms of this is better sustained attention for the treatment group. Okay. So then the other thing that we can do is, we've kind of provided, I think, some positive evidence that this is operating through a sustained attention channel, but as people have kind of gotten around to it, it could be that there's interaction of these things with the kids' motivation or their incentives to do well, and so we want to try to unpack that to a certain extent. So we do this a couple different ways. So one thing is that, if we think in general, if it's just that the kids, are more motivated generally, maybe they're more excited about school, or maybe they just like tests more now, or something like that, we would expect to see some effect at the beginning of that test, right? We don't see any difference in the treatment group in that first decile of the test, and so that doesn't really jive with just them being more motivated generally and working harder generally. The other thing that we can do is basically cross-randomize some incentive on the test. So what we did is we introduced basically toys, since these are 5 through 10-year-olds, based on the child's performance. So if they got a certain number of questions right, they got kind of the basic toy. If they got more questions right, they got a better and better toy, to try to provide some incentive to work hard on these tests. And we find a really interesting pattern. So first off, incentives work. Yay, economics. We see that students perform better on the test when they're in the incentive treatment. But it's not that this allows them to have more sustained attention over the test. if anything, they actually decline more during the test. They do better for the first couple questions. We see a big jump in their performance on those first couple questions, but they actually have more stagnation over the test, to the point where they still net do a little bit better, but it seems like they kind of burn out after that performance. And so it's not that our treatment is really just changing something about how motivation works. It seems like, if anything, these are kind of orthogonal features, and it's really that this is like an underlying muscle that even if you want it, if you haven't developed that muscle memory, it's not you're not going to be able to work on it. Yeah.
Christina, might there be though like a difference between like if I get a toy versus I've sort of gotten in the groove of enjoying this. Like one is like more of an internal motivation, and the other is an external motivation, and it could be that the external motivation is distracting because you're, instead of thinking about the problem, you're imagining the toy too, so couldn't it still be a form of motivation, just not the a different type of, it's an external motivation as opposed to internal.
Yeah, no, I agree. And I think that there could be some of that latter mechanism that you're talking about. The fact that we at least do get better performance at the beginning of the test suggests that there was some scope for them to actually kind of actualize this this incentive. But I agree that it's not clear that kind of your internal motivation or your internal interest would necessarily exhibit these same patterns when it comes to motivation and the interaction with sustained attention. So, okay, we could talk through all that. Great. Okay. And then the last thing that we do is to kind of, as I mentioned, try to test the extent to which this is just about grit or perseverance. So we can look at the effect of the treatment on questions specifically right after a difficult question. So we can see, is it just that this is just making you kind of more resilient in the face of difficult questions? And it doesn't seem like that's kind of how this treatment effect is operating. Okay. And then lastly, so kind of pulling this, kind of taking a step back, we want to see, did this actually matter for outcomes that we might care a little bit more about? Because it's not clear that we necessarily care about this abstract listening comprehension test or Raven's matrices. Did this actually have impacts on real outcomes for kids? So when we look at their end of term grades, they have like an end of term assessment that they do in their classes, we see overall about a 0.09 standard deviation effect. And this is true even in their non-math classes. So, in their Hindi class and English class, where really, in both of the treatments, they wouldn't have experienced really any type of content practice, we're seeing these effects. The other thing that we can do is, because we think they're probably better at taking tests, right? They can sustain their attention on these end-of-term tests. We can do a back-of-the-envelope calculation. Unfortunately, for their school grades, we don't have itemized question information to see how much decline they had. But if we assume, they had similar levels of decline that they did on our tests, that only explains about a third of the results. And so it seems to be that most of these effects are driven by the fact that we think that, if you have better sustained attention, you can pay better attention in your classes or on your homework or on your, classroom activities that you're doing. And so they're actually learning more, and that's translating into these higher grades in the end of the year. Okay.
Christina,
So that was this point.
can I ask one question on the previous?
Yeah.
With the live difficulty? No,
Yes.
yeah. So, the adaptive math practice, one way to characterize that is that it taught kids, you can keep we'll keep giving you harder and harder questions, but you can do it. You can run up a hill, right? With an increasingly steep slope on that hill.
Yeah.
But this is sort of the opposite of that. I don't know, maybe somewhere in this table the answer is lurking and I'm just not seeing it. If you reversed this, if you said did it help when the question got harder after the one you just answered?
Yeah, that's a good question of like, is it something about the slope of the question?
This is like got easier.
Yeah, exactly. That's a good point. Yeah, we can take a look at that. Yeah, Andrew.
Did you get immediate feedback on the listening and the ravens and the math, right?
No.
I guess I'm trying to figure out like maybe it's not a paragraph. Like if they had, would that change anything, right? So because did they in their training get immediate feedback?
Yeah, for both of the tablet versions, they're getting both after each question item and the math, and after, the puzzles themselves, they're figuring out like, did I solve this or not? So.
And that could be related to the internal motivation. Like
Yeah.
I like it because like I like it when that thing turns green. Correct. Check mark.
And I think one thing, so a lot of the psychology papers that have focused on this have been the thing that they end up testing. So they train on something and then they test on something that feels like a very similar task, very similar kind of modality, whereas ours look pretty different in a lot of ways than what we were training them on. And that was somewhat deliberate because we wanted to make sure that this wasn't really just something that we're training in something extremely niche, that this does have transferability to other settings. And so that was, I think, hopefully a feature and not maybe a bug for some of this. Great. I think I'm over on time, so I'll just really, really briefly give you a flavor of this last part of the paper. So what we try to do is just show, we were doing something very specific in our RCT of introducing these elective classes, but just does having more schooling cause you to have better cognitive endurance? So we're going to use birthday cutoffs basically for kids who are right below or above the age cutoff to be enrolled in school, and basically compare kids who are, essentially in this kind of 9 to 11-year-old range. I think some of whom are going to be 4th graders versus 5th graders, I think is the difference that we're going to be comparing. So there isn't perfect compliance right at the cutoff, but you have, about on average 0.22 years of schooling if you're, a December birthday versus the January birthday. And then we can compare, again, we have item level question data, and so we can see, do we see more predicted decline when this instrument for schooling, you have more additional years of schooling. So we see, in general, yes, for the kids who are 5th graders versus 4th graders but are at the same age, we see that they have less cognitive decline over the length of the test. And in particular, we see that this is stronger for schools that have better instruction. So they're spending more time on independent practice. They overall have higher pedagogy. So it looks like these are, the effects are there, but they're particularly pronounced if you were experiencing good schooling. Great. And then I'll just leave you with these couple figures, and then we can talk through some of the Q&A. But I think, broadly what we want you to have in mind is that we think this is an important skill in lots and lots of domains. We're showing that this is something that can be trained in schooling, but really we see this across the board in tons of different decision-making settings, that people have issues with cognitive endurance, and that there's big gaps by socioeconomic status in people's ability to maintain cognitive endurance over time. So I'll just leave those up and we can talk about those more, but I want to give time for questions. So thanks so much.
Questions?
Yeah.
I'm confused about the model you used for decline. Like, why didn't you? It seems like a natural time to fit something like a growth model or something like that of items, like looking at the rate of change over all 30 items rather than chopping it up into deciles and then grouping the deciles into ranges of deciles.
We did like a bunch of different things, and in like running it by people, what we ended up going with was, at first we had something much more complex, and we were doing, trying to do some different things with different functional forms. And what we liked about this version was just that it felt a little bit more transparent. Though I think, there could be different versions of kind of cookie cutter, like how much this was, matching to fit the data. But I will say, like, when we tried a bunch of different things, the results look pretty consistent. But I'd be happy to chat more too if you think there's something where we're just like missing, some variation in the data where we could kind of, use it better. I think the main reason we went with this was just that audiences seem to find the more complex stuff. They felt like, why did you pick that specification, if that makes sense? It felt a little bit more cherry picking, but I don't know. It's maybe a taste thing. Yeah.
So Christina, what I'll take the prize. I waited. I don't know if my wait time was good, but so I think I'm just trying to understand like the psychological mechanism. Like I think a lot of, I'm not a psychologist, but I think psychologists might refer to a related idea as executive function.
Mm-hmm.
And like there are other interventions like mindfulness, training that are also like focused on executive function, which I think show positive effects. But like figuring out what it is, like executive function is sort of being able to make yourself pay attention to something even when it's maybe uncomfortable to pay attention to, or when there's a lot of distractions going on. But anyway, just sort of, surely people have said, wait a minute, isn't this cognitive endurance related to some other psychological concepts? And how should we think about that?
Absolutely. So for a long time, we just called this sustained attention because under the executive functioning umbrella, there's working memory, sustained attention. I think there's one or two others people in this room probably know better. But this kind of falls under this idea of, these are underlying cognitive processes that you need in order to execute on your preferences and goals, right? We need these underlying abilities, like ability to focus on something, to hold multiple things in our head at the same time. And these are, concepts that psychologists have thought about for quite some time. So for a long time, we just called it sustained attention. Because psychologists tend to measure sustained attention as like the SART test, and some of these other tests, and those weren't our primary measures. Our primary measures was looking at performance over time. We ended up deciding, like, let's just call it something slightly different, even though, like, I would just call it sustained attention. I think they're fundamentally the same thing, and this is part of under this umbrella of executive function. So that was a little bit of the like background of where this terminology comes from. I would be more than happy if I don't want to invent a new term for cognitive endurance. I'm happy to call it sustained attention, unless psychologists in the room want to call me out on that being wrong. Yeah, Eric.
I want to invite you to speculate about sort of maybe future projects by like asking the question of like, what's the implication here for educational production decisions? Like, even if we just think about a teacher who's deciding like, how do I allocate class time? Like, if I want my students to eventually succeed in the labor force or in being better voters, like at the margin, should I spend more time on teaching how to add fractions with unlike denominators, or giving that time to help them improve their cognitive endurance?
Yeah, so I think what's nice here at least is I don't think there's a trade-off. I think that there's also nice work on basically showing, the difference in the effectiveness of kind of teacher-led versus more student-led, or giving students more opportunities for practice. And I think that also is better at teaching the concept itself. And so I think there isn't a trade-off in terms of those student outcomes. There's probably a trade-off from the teacher effort perspective, because I think it is harder probably to teach or to construct lessons that are able to do that well, as opposed to just lecturing. But I think at least on that dimension. But whether they want to spend a little bit more time at the margin, if there's some trade-off there, I would say I don't have the exact answer yet. But what I would say is that we should be doing more to understand, like, sustained attention is one piece, but there's tons of other things that I think in terms of the values or socio-emotional skills or emotional intelligence that schools are doing, and we just have no sense of both the way that teachers are able to develop that in kids and how that translates into longer term outcomes. So I would say, like, let's just measure all of these things to understand, how that translates to longer term outcomes, because I think that there's a lot that we're missing on the measurement side.
I honestly don't. There's a piece about this changing topics, and I'm not at all saying that I have any kind of determined position. I'm genuinely curious. You had spent a few sentences speaking to the ethical ramifications of the experiment you ran in terms of. It seemed like at many stages you were designing interventions that were essentially designed to be somewhat boring for children, things like that, and like the test we talked about earlier. I'm just curious your thoughts on that in terms of harm.
Yeah, so I think it's a really good point. So for this experiment, we were really, because we were getting at these kind of like, nitty gritty, cognitive and psychological channels, like you're saying, a lot of the measurement that we were doing wasn't really kind of obviously, one, it was probably annoying for the kids to do, and it's taking away from their regular classroom time. So we were really careful in our interaction with the school partners to basically say, okay, we want to do this, we want to take a day to do this testing. Like, what do we need to provide you in exchange for that to make sure that like it's both a good deal for the school system and for the kids? So whether this is, one of the main things that we did was to teach these elective classes, we freed up their regular school teachers, so they were then able to like either teach more sections or have more time for lesson plan and preparation and stuff. So we were, taking some of their existing staff's time to be able to teach these classes with our own staff time. Also provided all of the tablets and materials afterwards that they could use, and so we were very cognizant of the fact that like, some of the measurement that we're doing isn't probably the very best use of that child's day. So what are the other investments that we can make in the school to make sure that this is a positive relationship for the school system? So yeah, I think that was kind of the best that we could do. Was we felt like net our engagement with the school system was positive. And they wanted to keep working with us after, which I feel like is the only like true sign that this was something that they felt was like a productive relationship. So,
Thank you.
yeah.
So one thing that this made me think about was like test prep in the United States. So when I was teaching, I had one group of teachers who right before the state standardized test would find the most boring reading imaginable. And they said this, like the most boring reading imaginable, and create these like 60-page packets and make students sit down and read for an hour just so they could practice like sitting down for 1 hour and reading something that's not interesting to them. I would call that training, not learning. So it's like cognitive endurance might be helpful for like completing a task, but not building human capital. And you were careful to say that it may be the link to human capital, but like what do you think about the role of cognitive endurance in actually promoting learning?
So I think it's a really good point. I think that sometimes there are tasks that we want kids to do for goals that are like orthogonal to longer term things, right? So you're saying like the ability to do well, to understand how to strategize in a multiple choice test. That's probably not like an actual life skill that's going to make you better in in your job in 15 years. But we want to use that because that's the lever to measure these other things that we do think matter. And so I don't think that's what's happening here, in that I think that the ability to focus your attention towards something that you want to be able to focus on is a general life skill that's not just something that is about test taking. And so, but I'm not able to, look at these kids 10 years later and say, does this affect labor market outcomes? I think that would be the ideal answer to your question, to say like, yes, this actually is something that is not just about tests. Yeah.
I just wonder, just as a practical use, like find some test that has been linked to longer term outcomes like income or educational attainment or whatever, and see whether students' correct answers on the last half of the test are more predictive of those longer term outcomes than the full score.
If anyone has question item data linked to labor market outcomes, please come talk to me. We could not find question item level data.
So I think like there are some longitudinal studies that probably have that.
Awesome. I think I'm over regular time, so thank you so much.
Anyway, so thanks, Christina. Okay, so thanks everybody. Next semester, so I think this is the last one of this semester, but next semester we'll be back with, so I've got a list, Sarah Cahotis, Jesse Rothstein, and Bo Jackson over in the spring semester. So hope to see you back. And so for the PIER fellows, I think you guys know to stick around.
Thank you so much for having me. It was such a great program.
So